Hi, welcome back, guys. You know, whether you're studying arithmetic, algebra, calculus, or really any math, there are basically 4 operations that you need to learn how to do with each one, and that is add, subtract, multiply, and divide. And we've already done adding and subtracting, so now we're going to take a look at how do you multiply in algebra. How is that alike, and how is it different from when you learn to multiply in arithmetic? So let's take a look. The first thing we're going to look at is the notation. When you first learn to multiply, this is how you would write it. You would write 2 times 4 is equal to 8. And you use the time sign. Well, in algebra, you don't really ever use an x for a time sign, because now that we have variables, x is very, very often used as a variable. So we would never anymore use times, like an x, for times. Instead, we would do this. We'd write the same thing, but we would write it this way and mean the same thing. We'd write 2 times 4 is equal to 8. And so our notation can be a dot, which you've probably seen before. Or we could have 2 times 4 written that way. And that's just another notation that still means 2 times 4. Sometimes you'll see it with brackets, which look like this. 2 times 4 is equal to 8. All of that is the same thing. You've also learned back in arithmetic that if you were multiplying 4 times 2, you would also get 8. So it really didn't matter which one of the 2 numbers you were multiplying that you put first. And the same thing is true in algebra. Let's take a look at some examples in algebra that actually use the notation. If you wanted to multiply 2 by 3x, you might see it written like that. And you're like, well, how do you multiply that? Well, if you guessed, you would probably get it right. You just multiply 2 times 3, and you get 6, the number's in front, and then you have an x. In addition and subtraction, it was just a huge deal that you could only add and subtract terms if they were alike, remember? But in multiplying, you can multiply anything. Anything. You don't have to have like terms. You can just multiply anything. So we could not have added 2 and 3x, but we can multiply 2 and 3x. So 2 times 3x is 6x. Another example might be written this way. 5y times 3. We would multiply our numbers in front, 15, and we would get 15y. We could multiply more than 2 terms, certainly. So we might have 3a times 2b times 5. And if you want to multiply those all together, go right ahead. You've got 3 times 2 is 6. 6 times 5 is 30. And a times b, we write it this way, a, b. And that really means 30ab. 30 times a times b, 30ab. Sometimes multiplication looks like this, where you have a parentheses with an adding or maybe a subtracting sign inside it. And if you have those kind of problems, you just take this number that's outside and you multiply it by each one of these 2 terms. You multiply it by 7y and you get 14y. You multiply it by 3 and you get 6. Always, always take a look at your answer to see, is there any way I can reduce this, simplify this, add, subtract? Is there anything I can do to this to make it better? And no, there is not, because I'm into adding now, and I cannot add 2 terms that aren't alike. This is a constant term. This is a y term. I can't add those. So it doesn't matter how many. I might have 2 times 7a and 2b and 6c. And it doesn't matter how many are in here. I still multiply the 2 by every single thing. So I get 14a, and then I go 2 times 2b and I get 4b, and then 2 times 6 is 12c. So I end up with my answer being 14a plus 4b plus 12c. And I have 3 different terms in my answer. So I cannot simplify that or add those together at all. One interesting thing that we want to make sure we look at is what happens if we multiply by 0, because that happens a lot. So anytime we multiply by 0, we just get 0. So let's just see how that looks. If I have 0 times n, I would get 0. If I had 0 times 5, I would get 0. If I had 3 times 0, I would get 0. So remember that no matter what it is that you multiply by 0, I don't care how big or complicated, it's still the answer is 0. Anything times 0 is 0. Now let's look back at your fractions just a minute from your arithmetic as well, and remember how we multiplied those. In arithmetic, if you had something like 2/3 times 1/2, you might at that time have the x in there, but I won't ever do the x anymore, so you'll just see the dots. So 2/3 or the parentheses times 1/2, and when you're multiplying fractions, now think back, you multiply it straight across the top, so 2 times 1 is 2. You multiply straight across the bottom, so 3 times 2 is 6. And then you took a close look at your answer to see if there's any way that you can reduce it, make it more simple in any way. And so you already know from arithmetic that 2/6 can be made more simple. Your teacher usually uses the word reduce it. So you say, well, I can say 2 goes into 2 one time, or 2 divides into 2 one time, and then 2 divides into 6 3 times. And so I've simplified that down to 1/3, which is a better answer because it can't be simplified anymore. It's easier to understand, 1 out of 3 or 1/3. So always simplify your answers as much as you possibly can. Now let's take an algebraic example of a fraction. Let's take 4x over 5 times 3y over 2. And we're going to work that the same way. There's no reason to dread fractions at all. We already know how to work them. We're going to work it the very same way. We're going to multiply across the top. 4x times 3y is 12xy. Because remember, we can multiply anything. Now we do the bottom. 5 times 2 is 10. Great. That should be pretty comfortable. And now we look at that answer and we say, is there any way that we can either reduce that or simplify that in any way? So we look at it, we see the 12 and the 10, and we're like, yes, we can simplify that by 2. Let's divide both top and bottom by 2. So we say 2 goes into 12 6 times. 2 goes into 10 5 times. So our solution becomes 6xy over 5. And we're going to look at a lot more fractions as we progress and as we move into division. But just as a very introductory remembrance of how you handle fractions and what it looks like in algebra is what we're doing here. Let's take one more. Let's say we have 3a over 4, and we want to multiply that by 6c, we'll say. And I've been saying multiply across the top and multiply across the bottom. And then you look at 6c and you're like, there's no top and there's no bottom. So it's just like a whole number in arithmetic. Like if you just had 6, you would understand that to be 6 over 1. So 6c we understand to be 6c over 1. And so we can just write it that way. Now we clearly have a top and bottom. Multiplying across the top we have 18ac. And multiplying across the bottom we have 4 times 1, which is 4. We once again take a good close look and notice we can reduce our answer, reducing them both by 2. So we divide 2 into 4 and we get 2. And we divide 2 into 18 and we get 9. We still have our A and our C. So our final answer is 9AC on top and 2 on the bottom. Now I keep saying top and bottom, and you know the more sophisticated word for that, but let's review it again. The top word is called numerator. And then the bottom one, say it. See if you get it right. And I bet you do. Bottom one, denominator. Denominator. It's so neat to see the connections between algebra and back to arithmetic because there's so many. And you know how math just builds on each other, and so you can clearly see it this way. So we've taken a good little look at multiplication. Sometimes your key words, back to those word problems again, they're not going to say in a word problem, hey, let's multiply so-and-so by 3. They're going to ask you to find the product. So that's a key word that I want you to know. So one of your key words is product. And product just means multiply. The product is actually the answer, the solution that you get after you multiply something. So whenever it says find the product, you're like, oh, that means multiply. No problem. Product means multiply. Can't find a product if you don't multiply. The other word I want you to know in this segment for the sake of future work that we'll be doing together is the words factors. The word factors. Yeah, you did use it in arithmetic. You're probably thinking that. Factors are whatever it was that you multiplied together. Product is your solution. Factors are what you multiply to get the solution. Our factors here are 2 and 4. Our factors here are 5y, that's a factor, and 3. There's so much fun we're going to have with factors as time goes by. But what I want you to do now is practice this, rehearse it, master it, and I'll see you soon.